In this video, I'd like us to cover or proceed with bonding structure and the properties of matter. And before then, I want us to talk about electron configuration of elements. Now, elements have atomic numbers, and the atomic numbers are also equivalent to the number of protons, which are also equivalent to the number of electrons. Number of protons and number of neutrons are normally included in the nucleus of an atom, and the energy levels are normally occupied by electron. In our case, we have how many energy levels? 1, 2, and 3. This one represents the nucleus. And also keep in mind that the number of energy levels represents the period to which that element belongs. In this case, if we have energy level 1, energy level 2, and energy level 3, it means that the element is in period 3. Now, let us have a look at an example of, say, magnesium. Magnesium has the atomic number 12, and when we try to write the electron configuration of magnesium, it will be 2.8.2, meaning the total number of electrons is 12. It therefore means that magnesium has 3 energy levels. Now, the energy levels, it means that 2 electrons are covering or are occupying the first energy levels, then the preceding electrons are occupying the second energy levels, which is 8, and the last energy level, which is the valence shell, will be occupied by only 2 electrons. It therefore means that the valency of magnesium is 2. It therefore means that again that magnesium reacts by losing 2 electrons. Keep it in mind that metals react by losing electrons, while non-metals react by gaining electrons. And again, the electrons can either be shown in terms of dots and crosses in the diagram. Now, how do we represent metal ionic configuration in structure and bonding? I told you that magnesium reacts by losing electrons, and when magnesium loses the 2 electrons, it acquires the cationic property, which is 2+. It means that it forms a positively charged ion. The 2 electrons that are lost become 2+. Now, the electrons that are surrounding magnesium, we call them the valence electrons after losing the 2 electrons that were in the last energy levels of the atom. So in this case, these are the outermost electrons in magnesium ion. Now, magnesium ion can also be written as this one, meaning the 2 electrons are already lost. It means that the last energy level that the 2 electrons occupied is now empty. It does not contain any electron. Therefore means that the magnesium ion electron configuration will be 2.8. The 2 electrons that were there initially in the valence have already been lost. Now, let us try to look at an example of a non-metallic ion configuration. And in this case, let's talk about oxygen. The atomic number of oxygen is 8. It therefore means that the electron configuration of oxygen is 2.8.6. Sorry, the electron configuration of oxygen will be 2.6. My apologies. Now, since atomic number of oxygen is 8, the electron configuration will be 2.6. It means that the valence electrons are occupying, the valence electrons are 6. It means that oxygen has only 1, 2, 3, 4, 5, 6 electrons in the valence shell. How does oxygen react? Now, since it is a non-metal, oxygen reacts by gaining electrons. If the valence shell were occupied by 6 electrons, it therefore means that oxygen requires only 2 electrons to acquire the octet state or the stable state. And when an element gains an electron, it becomes negatively charged, and we call it an ion. Now, when oxygen gains the 2 electron, it will acquire 2 negative charge, and the electron configuration of the oxide ion will be 2.8. Now, I'd like us to talk about how ionic bonds are formed. Ionic bonds are formed when a metal ion combines with an unmetallic ion. In this case, let us have an example of magnesium oxide. Now, we say that magnesium reacts by losing 2 electrons, while on the other hand, oxygen reacts by gaining 2 electrons. Now, when magnesium loses the 2 electrons lost will be gained by oxygen, and that is how we form an ionic bond. It involves the transfer of electrons from a metal to a non-metal. And how do we write or represent an ionic bond? This is how simply we represent an ionic bond. The electrons that were lost by magnesium are gained by oxygen, and that is why the dots for magnesium are in oxygen, and magnesium acquires 2+ after losing. On the other hand, oxygen acquires 2- after gaining. So this will be the valence electrons in oxygen, and this will be the valence electrons in the magnesium, both ionic states. And we should always remember to include the brackets while we are writing the ionic bonds that are formed. Now, I'd like us to proceed by talking about in a case whereby we have an example of chlorine. Chlorine reacts by gaining 1 electron. Since it is in group 7 elements reacts by gaining 1 electron. Now, magnesium loses 2 electrons while chlorine only gains 1 electron. It means that for magnesium to lose the 2 electrons must be gained by 2 chloride ions. That is why we have 2 chloride ions in these brackets, and each one of them must acquire a negative charge, which is 1, because only 1 electron is gained by this chloride ion and 1 electron is gained by this chloride ion. Magnesium, on the other hand, loses the 2 electrons to these 2 chloride ions, and that is why we're told the overall number of positive and negative charges must be the same for a neutral ionic compound to be formed. When magnesium reacts with chlorine, it forms a neutral ionic compound. Now, let us try to have a look at sodium reacting with oxygen. Remember, sodium is in group 1. Group 1 elements reacts by losing only 1 electron, while on the other hand, oxygen is in group 6. Group 6 elements reacts by gaining 2 electrons to form an octet state. It means that 2 sodium will be required to lose each 1 electron so that it can give oxygen for oxygen to be stable. Assuming that sodium had a dot electron, these dot electrons on their valence atomic states, when they lose those 2 electrons, the oxygen will gain the 2 electrons that were lost. When sodium loses 1 electron, it acquires a net charge of +1. When oxygen gains 2 electrons, it acquires a net charge of -2. We said that, and always keep in mind, the overall number of positive and negative charges must be the same for neutral ionic compounds formed. Now, I'd like us to talk about some other things called, let me say, an example of polyatomic ions. When we have the word poly means many. So in this case, we have more than 1 atom of an element combined. So when you have polyatomic ions, they are 2, 3, 4 different ions combined together. Now, they can also be referred to as radicals. Remember, radicals are elements grouped together and they have a net charge and they react in combined state, meaning they cannot be separated. Now, an example of a polyatomic ion is ammonium ion. Ammonium ion has 1 nitrogen atom, 4 hydrogen atoms combined together, and it has a net charge of +1. Now, we also have hydroxide ion, 1 atom of oxygen, one atom of hydrogen with a net charge of -1. Then there is something that we also need to understand. You do not need to be able to draw out these ions, but you need to know how they use their overall charges to write the formula of the ionic compounds they form. Now, for example, a phosphate ion has 3 negative charge, nitrate ion has -1, sulfate ion has -2, and carbonate ions has -2. The charges represent the valencies of those ions. Remember, a valency, we can use it to calculate or to write down the formula of the ionic compounds that are formed. Now, this is an example of a carbonate ion that is formed when we have a carbon surrounded by 3 different oxygen. In this case, this type of bond that we have formed between non-metals is called a covalent bond. Now, remember, carbon requires how many electrons to be stable? 4, because it is in group 4. Assuming that the crosses are for carbon, we have 1, 2, 3, 4. It means that all these oxygen must give carbon 4 electrons. That is why this oxygen gives it 1 with this dot, this oxygen gives it 2, and this other oxygen must give it 4. Remember, we said that carbon requires 4 electrons to be stable, and it reacts by sharing the 4 electrons, and that is how we form such a compound. At your own free time, you can try to draw sulfate ion, nitrate ion, phosphate ion, hydroxide ion, and also ammonium ion. Now, finally, I'd like us to talk about the formula, or how we write formula of ionic compounds from wherever we have a radical, or rather a polyatomic ion, say an example of sulfate. These are some very simple steps on how to write it. Now, sodium ion has 1 positive charge because it is in group 1, therefore the valency is 1. While sulfate ion has 2 negative charges. Remember, we said that a sulfate ion has a valency of 2. Now, to balance the charges, 2 sodium ions are needed for each sulfate ion. Now, from our basic high school chemistry in Form 2, we are told that when we want to write the formula formed when sodium combines with sulfate ion, sodium is in group 1, but sulfate has a valency of 2. Because sodium is in group 1, the valency is 1. It therefore means that when we try to cross the arrows, 1 electron of sodium will go to sulfate ion, while on the other hand, these 2 will be exchanged to sodium, and that is why finally we'll have this general formula for sodium sulfate as Na2SO4. Now, it therefore means that this will be the general formula for sodium sulfate, and I hope you can try to draw the other elements. So this is bringing us to the end of the video or the tutorial. I hope you enjoyed it, and make sure you subscribe, share, and like the YouTube channel. Thank you. See you in the next class.